Hello students, this is Mr. Garcia, and today we are going to be going over an interesting lesson. Okay, and I want you to keep the following three terms in mind: inductive reasoning, conjecture, and counterexample. Okay, as I go through the lesson today, I want you to think about what those terms mean and the importance about those three terms. Okay, so I'm going to start going with the lesson now. Okay, let's get started with today's lesson. Today's lesson is Notes 2-1, Patterns and Conjectures. Okay, and this is something that all of us use every day. So let me give you the first term here. So the first term is inductive reasoning. So inductive reasoning is a type of reasoning that reaches conclusions based on patterns. Okay, so you're constantly doing this without even realizing that you're doing it. When you're watching TV, let's say for example, you're watching a movie, and then when you see the actors or actresses do something, you begin to try to predict what's going to happen next. Okay, sometimes this is what your brain does, and you don't realize this, but your brain is constantly working, and it's trying to break codes, which is what this is actually. So let's go over a couple of examples, okay, and then I'll come back and explain inductive reasoning a little bit further. Okay, so this is one example for inductive reasoning. Okay, so I'm looking at this pattern here. Okay, and I'm trying to break the code. So I see that this is the first term is 3, the second term is 9, the third term is 27, the fourth term is 81. Now I'm thinking, okay, what's the pattern here? So my brain begins to try to break the code. Okay, and the answer to this one is which number do you multiply by 9? By to give you 9. So 3 times which number gives you 9? Okay, 3. You thought, okay, let's go ahead and try that on the next one. 9 times 3, does that give you 27? Yeah. How about 27 times 3? Does that give you 81? Good. So it does. Now the question is, what's the next term? Or what are the next two terms? Or what about the next 3 or 4 terms? See, once you catch the pattern, you can apply that pattern to any term that comes next, and it's going to continue to give you the next term. Okay, so if I multiply 81 by 3, which is what I see the pattern is, the next term is 243. What if I'm being asked to find the next term? Then I multiply 243 by 3, and I have the work here. 243 times 3 is 729. So that's the next term. And the dots mean that this continues. So what if I want the next term after that, and the next term after that? I can find all the terms because I know the pattern now. The pattern is that each term is being multiplied by 3, and that gives you the next term, and so on and so forth. Okay? I hope that makes sense to you guys. All right, so let's go on to the next example. What about this one here? You're used to numbers now. What about letters? Can we use letters to send a code that not just anybody can break and therefore understand what we're doing? Right, we speak in code. I know you guys don't realize it, but sometimes we do speak in code. All right, so look at this letter, J, F, M, A, M. What do the letters represent? What do you think? Pause the video and think about this, okay? And then once you have an idea, go ahead and press play and see if you got the right answer. What if I gave you a clue as to what each letter represents? Let's do that. What if each letter represents the first letter of the month of the year? Does that give you a clue? And if you understood that, what's the next term? And the answer is J. So it's January, February, March, April, May. What comes next? June. And what about after June? July. And what about after July? August. And then? Get it? Now you see the pattern. Very good. So let's move on to the next term. Okay, so for this one here, I'm going to scroll this up so you can see that better. Okay, conjecture. This is what we're constantly making, and we just make conjectures on the last two examples. So, conjecture is a conclusion made by using inductive reasoning. Okay, it can't be true or false. Now, this is something that we use every day. We make statements based on observations. We catch a pattern. Now, this is the thing. Sometimes our conjectures or our conjectures can be false. And see, the thing is, we make decisions on false information sometimes, so we're making conjectures that are false, and the thing is that affects you as an individual, that affects those around you, that affects society, it affects sometimes all humanity. It depends on the position in society you have. So if you have a lot of authority and you're making conjectures based on false information, you can influence the lives of people either negatively or positively. Okay, so this is very important here. So let's go over the next term. And this is a counterexample. A counterexample is against the example. This is an example that shows a conjecture is false. You can prove a conjecture is false by finding one counterexample. So let's say, for example, your friend comes to you and says, oh, you know what? Ever since I was born, I've been looking at apples, okay, for the last, 15 years, 14 years. And every time I see an apple, I see that it's red. So then my conclusion is, based on my observations, based on the patterns that I've seen, that if a fruit is an apple, then it has to be red. And then you sit there and think, wait, that is false. That is not true, because I've seen apples that are not red. I've seen green apples, I've seen yellow apples, and they're not all red. I've seen them. I've seen the three colors, but they're not all red. So what you just said is a counterexample. So it goes against the conclusion of or conjecture of your friend. Okay, so that's what a counterexample is. So that makes your friend's statement that all apples are, that if a fruit is an apple, then it's red, makes it false, because you just gave them a counterexample. So, okay, so that's how this works. So let's go on to some examples here. All right. Examples. What is a counterexample for the following conjectures? So let's start with the first one. Okay, the first one is, if a month starts with the letter J, then it is a summer month. So pause the video and think about this. Is this a true conjecture? Is this a true statement? Okay, is it? All right, so let's see. I'm going to say, if you agree with me that it's false, I'm going to say that it's false, okay? And if it's false, then I have to give you a counterexample. So I'm saying it is false, and I'm going to give you a counterexample. And that counterexample is a month that is not a summer month, but it starts with the letter J. And I think you all got this one. So which is that month? That month is January. So there is my counterexample. I just proved that this is a false conjecture, okay? And I just gave you a counterexample. It's that simple. Let's go on to the next example. The next example says, if a flower is red, then it is a rose. We just discussed something similar to this, which was apples, right? I just need to give you one counterexample to prove that this is a false conjecture. So I'm going to say it's false. So I say it's false. And then here is my counterexample. My counterexample is a carnation. There are red carnations. They're flowers, but they're not roses, right? You can have many of them, right? You can also do tulips. You can do hibiscus. There are many flowers that are red and are not roses. Let's go on to the next example here. The next example is, you can connect. Now we're getting geometrical here. We're using geometry terms. You can connect 3 points to form a triangle. All right. Now, is this conjecture a true conjecture? I'm going to say it's false. And I'm going to go back to lesson 1.1, which was the flips. If you use the flips, or which was the notes that introduce you to the vocabulary in geometry, the basic vocabulary. One term there was collinear points. Okay, so collinear points are 3 points that lie on the same line, and you can connect them. You connect those 3 points and they form a line. They do not form a triangle. So I'm going to say this is false, and I'm going to give you a counterexample to contradict this making this conjecture false. So it's false, calling your points. Simple. That's my counterexample. You can try to argue with me, but I'm still going to say, no, your statement is false or conjecture is false. All right, and I just gave you a counterexample. So let's go on to the last example here. So for this one, okay, so for this one here, this one says, when you multiply an integer by 2, the product is greater than the original number. And as you saw, I'm saying that this is false. And you might be thinking the opposite of me. But don't forget what an integer is. Okay, integers is not just positive numbers. You also have negative numbers. So think about the product of two negative numbers, that's positive. The product of two positive numbers is positive. But what about the product of two numbers that have the opposite sign? Is that going to be a negative number or a positive number? With that in mind, false, counterexample, I'm multiplying 2, okay, but I'm multiplying it by negative 2. Negative 2 times positive 2 gives me a negative 4 because they have opposite signs, right? Now, is negative 4 greater than, which is what they're saying here, greater than 2? That is not true. So that means this statement, even though it sounds smart and very well stated, this conjecture is false. And I just gave you a counterexample. I hope that makes sense. And if you have a hard time understanding this video, just rewind and watch it again. And if you still have questions on the assignment or anything else, please let me know and I'll get back to you with the response or reply as soon as possible through Remind, Canvas message, or email. All right? See you soon. Bye-bye.